Hello again. So, problem 8.6. In trapezoid WXYZ, we have that WX is parallel to YZ. WX is equal to 17, XY 13, YZ is 21, and XZ is 20. Find the area of WXYZ. So, let's draw our trapezoid. Something like this. So, my two bases are WX and YZ. WX being the smaller of the two. So I have WX, YZ. And we have that WX is 17. XY is 13. YZ is 21. And XZ is 20. Alright, so we have to draw a diagonal. And that has a length of 20. Find the area of WXYZ. Well, we just said the area was the length of the height times the median. And in the last problem, we had the height. We just found the median, or we did a little bit of extra work, but we wanted to develop the idea first. So, now we are given the lengths of the bases, which means I can find out what the median is. So the median is the average of the bases. So that's 17 plus 21 divided by 2. Now, 17 and 21, well, that's 38 over 2, which is equal to 19. So now I just need to find the height. Now, how can I do that? Well, the height, again, the distance from the top to the bottom of the base. So what we have here, forming a 90-degree angle. I'm going to call this M. Now, we have two right triangles, but we're a little unsure about how to use them because we have MY, but we don't know what the length of that is. And we have ZM. I don't know what the length of that is either. So I'm going to say MY has a length of lowercase x. Don't get that confused with the point x. That's going to be uppercase. So ZM has a length of 21 minus the lowercase x. Because the entire length ZY is 21, subtracted with the length of MY gives you ZM. Now I can set up some equations with the Pythagorean theorem because I have the sides of a right triangle. So one of the first things I can set up is that h squared plus x squared is equal to 13 squared. And that gets us h squared plus x squared is equal to 169. Well, that's our first formula. Now I can make another one using the triangle XMZ, where we have h squared plus 21 minus x squared equals 20 squared. That means that h squared plus 21 minus x squared is equal to 400. Now I have two formulas with the same variable, which means that I can cancel one of these out by subtracting one equation with the other. So let's subtract this equation with the one here on the top. So h squared minus h squared cancels out. Then we have x squared minus 21 minus x squared equals 400 and 169. So that would be 300 minus 69. And 300 minus 60 is 240. That means we have a negative 231. Now we can start to simplify from here. Hopefully we notice that the thing on the left is a difference of squares, which means that I can, well, do I even want to factor that? Nah, not really, right? Yeah, let's not factor that. Let's just write it out. We have x squared. Then we have minus 21 squared, which is 441. Then we have plus 21x plus 21x minus x squared equals negative 231. And we just took FOIL, or just multiplied that out. 21 minus x times 21 minus x. So from here we can start to simplify. X squared minus x squared is going to cancel out. 21x and 21x is 42x. Add 441 on both sides. Now we have, well, 441 minus 200 is 241. Minus 30 is 211. Minus 1 is 210. And then we just divide by 42 to get that x is equal to 5. Wonderful. So now I know that this distance is 5. So now it's a relatively easy thing to solve for h. We have that h squared plus 5 squared, 25, is equal to 169. Subtract 25 on both sides to get that h squared is equal to, well, 169 minus 20 is 149, minus 5 we have is 149, 144, which tells us that our h is 12. Now, going on from there, we have that the area, I'm just going to erase some of that work we did. The area is the length of the average of the median, or no, the length of the median times the height. So W, X, Y, Z, we know that the length of the median is 19. We have multiplied by 12. And 19 times 12 is 228. So again, we're just taking these trapezoids and breaking them down into right triangles to make it a simpler problem for us to solve.